Welcome. This presentation is on cross-platform development. In this case, we're going to use the tool Apache Cordova, but I would ideally like to rename the talk because it's not necessarily about the framework that we're going to use or the tool that we're going to use. These principles and a lot of the things that we're going to review apply to tons of different frameworks that are out there. So, hello, my name is Ben Rondeau. I am a developer advocate for IBM Bluemix. That is IBM's platform as a service. If you're familiar with Heroku, Azure, Google Cloud Engine, there's lots of similar products that are out there, and Bluemix is IBM's offering for that. It has some great services and things that help set it apart. I won't get into that, but I encourage you guys to visit the IBM booth that is upstairs and check out what we have to offer. They're giving away free trials and all sorts of other stuff like that. And if you didn't hear earlier, here is the link if you'd like to view the presentation on your screen. It helps if you don't have a good view. And then also, if you are navigating it, if you notice at the bottom part of the screen right here, there's some arrows. It's a two-dimensional deck. It's not just right to left or left to right. Some sections are vertical, and so if you just go right to left, the presentation will seem like 6 slides long, but in fact it has vertical. So make sure that you pay attention to that little guy down there. So welcome. Our multi-platform world. We have so many devices that our users are consuming our content on, and it used to be just desktop devices and a couple of mobile devices, but now internet browsers, internet connectivity is now a real possibility on televisions, which is a totally different form factor, a totally different way of interacting. So with computers, you've got a mouse and you've got a keyboard as your input devices, and the screen is relatively, maximum maybe 17 inches on a laptop. You might have a bigger display, but the form factor doesn't really change. When you have a mobile device, the main input for that is going to be touch. You also have voice, and you also have video and pictures as well for input. So that definitely adds a layer of complexity and also opportunity to the applications that you create, the experiences that you create, even if it's just in a mobile browser. But now we've got things like web-connected televisions that have got browsers, things like that in there, and the main input device for that is going to be a television remote. It might have a gyroscope or what have you in it, like the Apple TV remote. It might have like Amazon Fire TV. Their remote has got a microphone built into it, so you can interact with it, as well as Apple TV One has that was just released, has one that you can speak into, and that's another input device. And then you've got vehicles that are becoming connected. There's not really browsers in vehicles yet per se, but applications are able to be put onto different vehicles, and the number of platforms is just increasing exponentially. Also, we've got wearables, which watch is the most common, but I just saw, I think it was on Wired.com, there's a shoe that's now connected. You can actually have a mobile app, and your shoe can marquee like text across it, and you can have different patterns and things like that. So now we've got to create experiences for shoes. And so it's quite a diverse platform, and it's just getting more and more diverse. And the expectation is also increasing as well with the number of experiences, as well as if you think about it, the number of ways in which people can consume the experience that you want to create. Maybe it's a music app, maybe it's social media, maybe it's, who knows, some new area that you want to explore. People want to deliver it on the device that they like, so mobile or wearable device or what have you. If they don't have it, they move on to whoever can fit their need, and so the demand for that is really important. And you've also got different platforms. So when it comes to desktop, the obvious ones there are Mac OS X and then Windows, or Microsoft Windows. But then you've also got Linux, if there's any Linux people out there. And then on mobile, you've got different operating systems such as Android, iOS, BlackBerry, Windows. You've also got some, like for example, Firefox OS and other operating systems that are out there, and people want to consume on the platform that they use. And creating a good user experience is meeting users where they're at and not expecting them to get onto your platform, your device, etc. And so the complexity is just increasing. And then talked about this is CarPlay. They haven't released a SDK for this yet, but it's just a matter of time and before there's an SDK for like a spaceship or something like that, in which it's like, got, this super, important platform that we've got to support. And I think you all get the gist by now of what the landscape looks like for developers. And then this is a usage chart from March of this year, and you can see that if you target just one platform, let's say if you target Android, that's 58% of users. But if that's the only platform that you target, in this case, 42% of users are not going to be able to use the experience that you want to deliver. If you target iOS, if that's your thing, and you've got 36% market share, that means that 64% roughly of users out there are not going to be able to consume your experience. And depending upon where you are, if you're here in Europe, or if you're targeting in Africa, India, Asia Pacific, the United States, South America, the statistics can vary widely. And so you might have an experience you want to deliver to South America, but if you're on iOS in South America, it's much more likely to be Android. And so your market percentage can go from 36% to 10. Or 5 or what have you. And so having tools that you can use to port your experience across multiple devices and platforms is critical. So you've got roughly 5 different options available to you. You can kind of expand and contract on these, but there's roughly 5 different buckets. First is a separate native code base for each operating system and device. And holy cow, that can be incredible. Do we have any mobile or non-web developers in the room that have created an app, played around with an app? All right, I think we got 2 or 3. Okay, well then I'll delve a little bit deeper into this. If you ever get to playing around with Xcode for iOS or for Android Studio for Android, you'll experience very quickly it's not just about knowing the language. For example, Android is written, applications are written in Java. Just because you know Java doesn't mean you know diddly about writing applications for Android. There's an SDK or a software developer kit that you use to talk to the APIs, like the microphone and the camera and the contacts on the phone, etc. And it's a totally different learning curve. And you've got to deal with devices and provisioning profiles and submitting it to an app store to get approved. And it's a totally unique skill set on top of knowing the language. And once you multiply this across different platforms, and so like iOS, which is Objective-C, which is first the worst language ever written, but second, it's a totally different experience. And then, for example, if you got iOS for your mobile device, but then you've got WatchKit, which is kind of an extension of iOS, but it's kind of becoming its own thing. You've got 2 different SDKs just for that operating system and just for that language. And so separate code bases is the way to go if you've got $1 billion and tons of developers, but it typically isn't workable for most companies and developers. The second is JavaScript and native rendered apps. This is a trend that's about 6 or 12 months old, and there is a presentation on React Native, which if you're familiar with Facebook's React library, they created a platform for you to take JavaScript that was written in React and JSX, and then render mobile applications using their tool. And the presenter will dive into that in the same room about 2 hours, or I think it's about 6 o'clock. I encourage you to check that out. Third option is hybrid apps that mix web and native components. And I'm going to demonstrate examples of all these, God willing, if the presentation works. So you can see what they look like. Fourth is an HTML5 app, which is just like basically a web browser that they wrap in a native app container, just put on a phone. It's basically kind of just like a web browser and a phone. And then you've got web browser based. So the first option is native. The pros or the reasons you want to use this is you'll have the best app experience for each platform. So the user interface, interactions, the performance, etc. And many experiences are not possible any other way. So complex animations, interactions, gaming, etc. is just not possible in any other way. But the con to this is the most expensive and difficult option. Each platform you develop for requires a unique skill set, coding language, software tools, and devices. It is an enormous undertaking. And what I'm going to do now to give you a little demonstration, how many of you all use Spotify? Okay, great. So you might be familiar with this feature. Let me pull it up, hope it works. Boom. Okay. So a couple of things I want to point out that you notice as I go through some different apps and you can see different experiences. First is that the interface itself is so fluid. You notice that it kind of has somewhat of a natural gravity effect. So as I swipe up and then I let go, it kind of slows down and then stops. And if I get to the bottom and I keep on scrolling, it will come up, but it will kind of spring down. And so that's the native UI engine that is monitoring where the content is on the screen and then adapting to it. And you see, for example, like on this image right here, I can pull down and kind of zoom into it. This is something that's really only possible with a native device. And let's say, for example, I want to choose the morning run playlist. What I can do, and hopefully I can get this to work, but this is picking up the gyroscope inside the phone, and it's using an algorithm to time the up and down motion of the algorithm. So I guess I'm going 140, and eventually it'll start picking songs that are roughly on that tempo to kind of have a cadence as I run or as I exercise to it. And you notice there's a very rich user interface. There is a animation that is rendering probably about 30 to 60 frames per second. And that is something that, depending upon your application and what's going on in the background, it may become jittery or stop if you've got a lot of processing on the background, because in applications that are not native, you're stuck to one single processing thread. Whereas with native, you can do multi-threading, so you can have graphics on one thread, and you can have networking on another thread. You can have, rendering on another thread. Whereas on hybrid, you're going to have one single thread for everything, and you're not going to be able to achieve that. So let me see if I can go backwards and forward. So I think you all get the gist on that. The second option is JavaScript to native. This is very, very new. This is very cool as well. The pros for this is a native app that is rendered despite a code base being written in JavaScript. So you can write a mobile app or an app for any sort of platform, and you can use a tool to then create an Android or an iOS, more platforms coming, for that application, and it is actually running as native code. Your users will not be able to tell a difference, if it's written well, between a native app written in Objective-C versus an application that is written in JavaScript and then executed with the device. There's also live debugging in a running app. If you use, let's say for iOS, you use Objective-C, you've got to compile. Objective-C doesn't run or interpret, it has to be compiled, and so you've got to run through a compiler. And for example, Facebook's app, it takes about 20 minutes to compile that for iOS. So think about if you make a change and you want to see how it works. So you got to make your change, take about 20 minutes to compile it, and then it's running on the device. You're like, oh, I don't want to do that, I want to do something else. In order to debug it, you've got to stop the app, you've got to make the change, and then rebuild it. Whereas you can actually debug live because you're using JavaScript, which is an interpreted language, not a compiled language. I actually do the same thing, but I won't get into the details, it's not really that important. But you can actually debug in the app. Huge, huge benefit. The cons, though, is this is the newest option available, thereby it's the most prone for issues and bugs. For example, today there's 836 open issues on React Native, which is probably the leading library framework in this area. That's a lot of issues to solve. The community is small, which is reflected in resources to learn it, so not as many. Code samples, the amount of support that you can get. It's kind of the Wild West. You head out to explore, and if you run into a problem, you've got to largely solve it yourself. And that can be very difficult if you're not familiar with the operating system languages and SDKs that come with these platforms. So here's an example. This is AIGA, which is American Institute of Graphic Artists in the United States. Not sure if it's in Europe or not. Oops. So this is an application that's written in JavaScript. Keep in mind, there's no Objective-C, there's no Java or what have you. This is purely JavaScript. And it's going to update real quick. And so you can see, as I scroll through, it's got that kind of natural kind of bounce gravity effect. If I kind of scroll up and slow down, my screen's a little short, but you can see that native effect is present in this application. If I go to, and you can see that kind of nice kind of scroll up and scroll down there. If I head to the map here, this is a map that is embedded into the application, and and it crashed. Boo. See, this is, I told you it was new. Okay, let's pull up the map here. Fingers crossed. And you can, come on, one more time. What I will do while it's loading, as you can see on this picture here, there's a map that's got a custom user interface on top of it. It's got a custom skin, and then it's got these different options to find things on the map, and you're able to pinch in, zoom, move around. When you click on an item, it pops up. It's very silky smooth. It is very much a native application experience, and what's incredible is this is written totally in JavaScript. There's a, like I said earlier, there is a session on this. I think it's 6 o'clock tonight in this room. I'm going to be here. I really encourage you to be here as well. The third option is hybrid. So this is the pros for this is that you can mix native device features with a web application interface, which reduces development time and skill set. So you can write maybe 80-90% web app and then add in some native, and then you've got a app experience that is pretty awesome. We'll show you some downfalls of that, but it can get you there much faster, which is what the second point says. The cons to this is that you're simulating the user interface and the interactions. They are not native. So let me open this up here. This is a user interface library called onSen, and what you'll see is there's a lot of user interface items for, in this case, iOS that is built with using HTML5 and CSS, and it looks, pretty incredible. Like this switch right here. If I open this up, you can see here, if I touch on this, this looks just like the slider on iOS. And but you can see here, it's just made out of HTML and CSS. So you don't need to know any native development skills in order to use this. But the thing is that you are emulating it, and that can be really buggy depending upon what you're trying to do. This interaction is pretty simple. Like here, we've got you've got range that you can go backwards and forward just dragging. But once you get into more complex interactions, this can become very buggy, if not impossible, to do. And the difference in quality can be quite noticeable. This is a hybrid app that is on the App Store, and it's actually got incredible ratings. And you can see here I included a screen for Apple Watch. So this app is mainly using a framework called Ionic, which is an HTML5 CSS JavaScript framework, and it uses some native plugins, in this case WatchKit, and it's grabbing, you can see here, the pulse of the person that's working out with their Apple Watch is being sent back to the iPhone, and then it's being calculated into the workouts and things that WatchKit does. And so that's a pretty rich experience for an app that's probably 70-80% HTML, CSS, and JavaScript. And so I've got a screen here. You can see as I'm going up and down, I can't bounce. So if I go to top, it just stops. So that may not be the end of the world, but you can see that the native user interface and the interactions that people are going to expect are not there. This will get worse as we go on, as we go down and down in fidelity, but that can make a big difference. So you can see this is this is pretty smooth. Not too bad. You can see, if you're familiar with the iOS UI, you can see that the proportions here for these menu items is not exactly what it should be, but it's pretty close. It's not too bad. And you can see right here we've got some wonky buttons, right? You can see why, for some reason, when they're including this, what do you call this thing? Slider? You can see that it doubles the size of the frame that the text is in. And I guess it is right here as well. So you can see here it's just kind of oddly fat. If I go into the settings here I've got on my iPhone, you can see here that when I have a normal cell, that if I turn this on and off, that it doesn't double the size. So you can see that, it's not really the end of the world. Most people are not going to notice. This app has got thousands of hours of development work into it. But you can see here we're starting to slowly diverge away from the native experience. In this case, we've got a bounce effect. It's pretty good, but depending upon which frame that we're on, it can vary widely. Sometimes you can go left to right on these, even though you're not supposed to, and it's pretty weird. This is actually a pretty nice app. I encourage you to check it out. So now we've got HTML5 app, which this goes all the way back to like 2010 or so. Once these multiple platforms came up, iOS and Android were the first two, they're like, do we have to maintain two separate applications altogether in order to do this? That's just way too much work. And so they came up with Cordova, which we'll get into shortly, which is a way of creating a web app using HTML5, CSS, JavaScript, depending upon what you want to do, and then wrap that kind of like in a native wrapper that allows you to put that code onto a phone, just like a native app. But in reality, the code base for the Android app, for the iOS app, etc., is going to be like 50, 60, 70, 80, 90% the same, which makes it much faster to develop and integrate changes, get to market, etc. But the cons for this is you get what you pay for. It's going to be the worst experience on native devices. So let's check out Muse a bit. I hope the developer for this isn't in here. Sorry. We can see here, this isn't too bad. We kind of got a bounce effect, but you can see here that I've got graphical elements that are overlaying each other. And it's not the end of the world, but it's just kind of funky looking here. You can see here that these, it's kind of hard to tell, but if you're looking on the device, the ratio for these cells right here is just not correct. The developer did not do a good job of that. And you can see here we move on to this screen, and now the same cell, so the same graphical element across different screens is now different sizes. So I'll open this up and you kind of see the different sizes there, whereas if this was native, it would be the same all the way across for a better user experience. Let me see here if I can pull this up. So you can see here, so I've got these elements that are overlapping. This text is unreadable. And you can see that the library text at the top and then the icons along with the other text, it's just funky. You can tell like something's wrong with it. And let me see here. This text right here is unreadable. Let's see here, news here. This is probably one of the worst screens. So you can see right here that this just feels empty and kind of wrong. And now I've got a loading icon. Oh, at the bottom, there you go. And this used to be much more pronounced and worse, probably 5 years ago. This has kind of moved forward. But if we dig deeper into this app, it just feels wrong. And if you're and you can see this app is basically just kind of a list, and it's got different screens with different lists on it. Once you get into applications that start having animation, start using device APIs such as the accelerometer, the camera, Touch ID, or fingerprinting on different mobile devices, then the difference becomes enormous and noticeable, even by people that don't know development. They're like, hey, what's going on here? This app just feels weird. And then in-browser app. The pros to this is the highest compatibility. Basically, you create one experience, and then pretty much everything's got a mobile or a browser on it. And so there you go. You're covering 100% of your bases right there, mostly. And you only need a single set of development skills. But the cons for this is it's limited by what a web browser can do. Access the native devices APIs, which I'll list those out later. That's things like the accelerometer, the camera, GPS, and all sorts of other things like that are not accessible to a web browser. It can be severely limited. And if you have your phone, I encourage you to pull it out and actually try this out if you can get signal. The address is tap.unicef.org. And I'm going to open this up. And this uses let me pull it up here. This is a project. It's an HTML5 website, obviously. It's in a mobile browser. And what it does is it taps into the accelerometer on your phone to detect movement, and it's encouraging people to put down their phones. I think if you put down your phone for 10 minutes, it provides clean water for somebody, and so it's waiting for the device to be steady, so I'll hold it still. The quality of the accelerometer feed is not great. So you can see I've got a ticker at the bottom, 6, 7 seconds, etc. If I move my phone, it'll give me 10 seconds to steady my phone. or else it will end. And I'll stop moving it at 3. And the accelerometer feed to it is not so great, so the experience isn't wonderful. But I think it did an incredible job with this site. It's I don't know why they don't just give clean water to anybody. If they have the resources, why not just do it? But so you can create a mobile experience, or an experience that you can port across different devices. In this case, accelerometer is a key part of the experience. But you can still create a mobile app, or excuse me, a experience inside of a web browser that can take some of these capabilities to be a part of it. But depending upon what you want to do, this may be a great fit, but it may not be a fit at all. So now we're going to talk about Apache Cordova. Apache Cordova is a platform for building native mobile applications using HTML, CSS, and JavaScript. This is not an accurate statement anymore. They just haven't updated. It's not just mobile applications. It's now desktop applications, and they're also moving into more like wearables and kind of the newer generation of devices. But it takes a while to get all that code put up. So the goal of this tool is to provide a single or similar, in most cases, code base to develop applications for multiple platforms from. So I'll show you what this looks like. So here are current platforms that you can write your web app in HTML, CSS, and JavaScript, and then using a command line prompt, you can just create a BlackBerry app, Firefox, iOS, Mac OS X, Windows Desktop, Qt, Tizen, don't even know what those are, but you can create one if you want to. The device APIs that you can access with Cordova, you don't have to write a single line of native code for Android or any of these platforms. You can get the battery level, camera, the console, which that's more for development, contacts, device, information about the device, what device it is, resolution, etc. Device motion, orientation, the file system, so you can actually store files on it, like high scores, things like that, images that it take, etc. You can't do that in a web browser very well. File transfer, geolocation, globalization, in-app browser. If you have let's say Facebook or Twitter, if you click on a link, it'll keep you in the app in a little browser inside of there. It's to try and avoid you from going outside the app and then never coming back, but you can include that in there. Media capture, network information, splash screen, status bar, vibration, and this is probably only half the things that you can do with that without writing a single line of native code. So this is the perfect solution, right? No. Not exactly turned out like they hoped. The right time for Cordova. Your app can be created with current web technologies and accented, complemented, part of that way of saying it, by native device capabilities, such as a web app that uses push notifications or something like that for a asynchronous kind of experience, like Slack. We'll talk about that later. Your app doesn't need complex animation, such as 60 frames per second at 1080 resolution. There's some apps out there like Vainglory, if you've heard of that, for iOS. That was the app that was created to demonstrate the new graphics engine. There's absolutely no way you could do that in web. It would just explode, and it would be jittery. You wouldn't be able to interact. It's a multiplayer game with characters, and you attack other people's forts, and you explode them and stuff like that. There's no way you could create that in web. Your app doesn't use complex touch interactions. You can use pinch and zoom, like if I go into my browser here, I should be able to kind of pinch and zoom. Actually, I can on this because it's not going to allow me, but I think maybe on Codemotion, nope, it won't allow me. But you can do pinch and zoom and other things that are built in, like tap, like that are built into the web browser, but doing things like with using the touch interface is like triple tap or what have you. If you want to do a custom interaction for that, you're not going to be able to do that without native code. Your app is not a resource hog. If you need a lot of memory, a lot of CPU, a lot of rendering graphics, remember you've got one single thread to do everything on networking, graphics rendering, anything that's going on in the background. You can't have a whole lot of that going on. And your app doesn't need cutting edge support. So if you want to support the latest wearable like Apple Watch, like a day after it is released, then you can either write it yourself, but if you're going to write it for yourself, why are you writing a hybrid app? But second is that it takes a while for the community to write the native code necessary for Android, for iOS, for that feature, and then to release that onto the wild and test it. So 3 to 6 months lag sometime. So I'm going to show you guys a demo. How many of y'all in here use Slack? If you don't, I'm sure you will very soon. So I'm going to pull up. Here I've got, this is a good example of a good use case for using a tool like Cordova to create an experience across multiple different devices. So I've got here a native app, to my desktop operating system. I'm going to open it up in my web browser, and this team that created this has done an incredible job with fidelity. I'll show you what that looks like. And then I'm now going to pull up Slack, my mobile device. And what you can see here is that, so I've got my mobile app here. I've got the desktop app here, and then I've got the web browser here. The fidelity matches across devices. I don't have like a custom interface for each device. So this would be a great use case for using a tool like Cordova. On my desktop native, this is what the pop-down looks like. On the web, this is what it looks like. They've done an incredible job of matching fidelity across the different platforms. If I click on, click out of this. If I click on the info button here, this will kind of slide out. And if I do the same here, this will slide out. And you can see it's almost identical across the platforms. And then let's say that I want to send a message. So you can see, probably can't see very well, but at the bottom here, I'm going to say hi from mobile. And then that's going to replicate across all of these platforms. And the reason why this is a very good use case for Cordova is that, or a tool like it, cross-platform development, is that it can be recreated in these different interfaces well and then accentuated by the device features. So for example, push notifications would be perfect for this. You can do desktop notifications. It's not, on a web browser, it's not the same as native experience. But then you can integrate things like Touch ID for authentication. You can integrate sending someone your location from the mobile app just by the touch of a button if you use the mobile app, and that can send across all the devices. So this is a good example of when you can use a tool like Cordova in order to create a experience across multiple different platforms, in this case 3, with very little effort. And I'll show you what that looks like in a bit. So the wrong time for Cordova, talked about that stuff. The gap is narrowing. We did cover some of this. There's some frameworks like Ionic is probably the most popular now for hybrid application development. They've now got a whole suite and ecosystem. So you can download the boilerplate code. You can actually create an app using a web browser UI, never touching code at all, just dragging and dropping and then push it to your phone. You can add things like push notifications, data, things like that for your application. And it is very friendly all the way across. It's come a long, long way. But it's not going to be perfect. It may be perfect, it may not be based on your situation. And then, for example, React Native. I encourage you guys to check this session out later. Here's the remote debugging I told you guys about. But this is a way of just writing JavaScript that goes straight into native code. And the gap between native apps versus non-native in some portion is really narrowing. So an ideal path, if you're not doing cross-platform development and you want to get started with that, I encourage you to start trying out with hybrid apps using native plugins, which I'll demonstrate that in a bit. Start developing your own native plugins and contribute to the repository. Those native plugins will be written in the specific operating system code in the SDK. So for iOS, it'd be Objective-C using the iOS SDK. And you start to get your feet wet with a plugin, a feature here, a feature there, without writing an entire app from scratch. And then start using more native code than hybrid coding applications. And it's a really nice way to go from no native experience to full-blown native development without just making the jump in one leap. So we're going to finish this out with building an actual application. So there's a command line tool. Hope everyone can see this. The binary is referenced by Cordova. You can install this if you have Node on your machine or npm install Cordova-global. And once you do that, it'll download the binaries necessary to build your applications for Android, etc. And whatever resources it needs, it'll just pull down from the web. I've already got that installed. And here are some options that you have available to you. So you can create an application. You can add different platforms like Android, iOS, BlackBerry, etc. You can add plugins. You can compile the app. You can run it. So you can actually show it up in an emulator. And this is pretty incredible. You can, if you're not familiar with iOS development, you have to have a Mac, and you have to have Xcode in order to do that. But using this Cordova tool, you could have a Windows machine. You could compile a app for iOS and push it up to the App Store without. Well, that'd be really sketchy. You have to like cross your fingers that nothing blew up during the compile phase, and you wouldn't have to have a Mac computer in order to do that. So what I'm going to do here is on the desktop, I'm just going to create an app. So Cordova Hello, which would be the name of my app. Oh shoot, sorry. Cordova, wait. There we go, sorry. Cordova, create, hello. And it's created my app for me, so I'll open that up in Sublime Text. I hope you all can, sorry, I know this is probably pretty small, but let's see here. What we can see right here is there are a couple different folders that it scaffolds out for you. It's got this config file, which this is kind of the home for all of your different deployments. It's going to pull information from here. So you've got plugins, you've got platforms that you want to write to, and it'll update this as you change things. Here's the name of your app. Here's the bundle identifier that you'll need for the App Store as well as your apps. Inside of www is the HTML, JavaScript, and CSS that you'll use to create the base of your app. And then when you want to add platforms like Android, iOS, etc., it'll copy this code out of there, it'll wrap it in the native code necessary, and then it'll be able to just launch up your app in that device, which I'll show you what that looks like in a moment. And here's where you can add plugins as well. So here's what those folders look like. I'm going to open up, let's see here. Actually, what I'm going to do is I'm just, without even touching the code, I'm going to create, so Cordova platform, add, iOS. What that's going to do is it's going to take all the code that is in my www folder, which is my web app, and then it is going to build it. It's now installing a plugin. It's pulling it down from the web. In order to do that, and my connection is kind of hit or miss. But eventually what it will do is it will finish building the binary that I can use to just launch my app and create it. So, do I have web access? Yes, I do. Okay. While this is building, I have an app that I've already created. This is, I'll show you what the web app looks like. I'll just pull it up inside of a browser. So I'll pull it up inside of Firefox here. And you see this is just Cordova, this is just a chat application. This is kind of like Slack, but a very simple version of it. And I can add a message to it. So my username will be web browser message, hey, from the web. So I can add that in there. And something that I can do is I can use geolocation inside of a web browser. And I'm going to post my location to this chat room to let people know where I'm at. I have to share location in order to do that. It'll grab it. It'll send the coordinates off to Google, and then boom, there we go. That's where we're at. This has nothing to do with Cordova. It's just a Ajax call to Google. But I'm just showing you the web version of that. And so once I go to I think we stalled here. If I do Cordova platform add iOS, what that's going to do is in my platforms folder, it's going to add the iOS folder. So once I click on that, I've now got my Xcode project, which if you're not familiar with Xcode or with iOS development or OS X development, then Xcode is the IDE that you use for creating Mac applications of different kinds. And here I've got my app in here. And inside of here you see my www folders. This is my web app right here. You can see my HTML right here. And inside of here, I can then add all sorts of different code if I'd like to. Like here's a header file for C developers, if you're familiar with that. And then here's the body file. You can see how ugly this is. And oh wow, okay, really is ugly. See if I can make that bigger. Window zoom. Oh shoot, okay. But you can see here I can adjust the native code if I want to, or I can just launch it straight on my app. Excuse me, straight on my phone. And let's see here. So here is my So there is my app that I have not changed a single line of native native code for this application, and I can add in here mobile, from iOS, and I can add that up there. And then if I go back to my web browser, I can see that right there. And then, if I want to, I can use the native device capabilities to post my location, to retrieve my address, and it should probably put up the exact same one. Oh, a little bit different. And I was able to create, this is an app that's running, so you can see on my phone, if I close out of it, Cordova chat is up here in the corner. And this is a native application. I could send this to the App Store. It would be the stupidest app that's on the store. But it's a native app that I have created without a single line of native operating system code. And stop that. And then what I can do from there is I can make, let's see here. I can make whatever changes that I want inside of here. So I can go into my HTML file and I can change the name of the app. Right here, I can change the way the app works, that it looks, etc. And then I can just run a simple script, which would be Cordova build. It will repackage my changes into a new iOS app, and then I can launch it again without having to do any native development. I can do the same for Mac operating systems for the desktop or for Windows or what have you, and then from there add in whatever I'd like to. I can also add plugins like the I'll show you right here. In my plugins folder, you notice a folder here. It says Cordova plugin geolocation, and this is what's talking to my device. And I'm pulling this in with just some JavaScript at the bottom right here. This is my code to get the geolocation right here. And this is referencing that plugin right there. So I'm using JavaScript to get that information from the phone. And then I just throw it up into my app using this code right here. And I'm able to do that right from the command line. So, let's see here. So I hope that demonstrates what cross-platform development looks like. One of the tools that you can do one of the tools, in this case Cordova, that you can use to build that, and then how with knowing no native operating system skills, you can actually create mobile applications or desktop applications, etc., to send out, and then you can develop from there. So I encourage you, if you want to check out this, all the links and information that's on here. This is the address that you can use. We have 2 minutes left. I'm going to open it up for questions if anyone has any. Yes?
Deploying the apps, especially in the app stores, when you have this burden, especially in Apple, when you have 1 week to wait until that deploy. I know that in the past there were, at least a couple of years ago, there was a restriction about downloading code. I also know that companies, even large companies, were taking this consideration into account in a strange way and were downloading code into the application from their servers in the daily basis. It reduced the time to market of the application. And what's the status of that? Is that still taken into consideration when choosing one of these technologies? The option to download the JavaScript code and execute it in order to release or deploy new versions?
Yes, for those of you that didn't hear, for those of you on your way out, please drop off the evaluation form if you can. But the question was about, for an iOS app, launching that to the App Store. When you do that, they will reject your application if you're downloading code from the web somewhere. They want all the code to be packaged all together in inside your app, and not to grab resources from like the cloud or for what have you and pull it down, because if you do that, then you can then change the code, and it's an injection vector for hacking someone's phone. And so the question was, what's the status on allowing that? To my understanding, they have they do allow it under very stringent cases, but it is an attack vector, that so for the JavaScript that you inject, or let's say change the functionality of the app, if you then inject some code that is trying to grab device information, what have you, and then send that to a malicious web address, then if they open that up for you to do that, that's a possibility. And so it is allowed, but it's under very stringent limitations. And there's a big push for that because it takes a week, like you said, to get your app approved once you put it on for the store. And if you've got a lot of updates to do, if your app is broken, you can be in hot water. And so it is allowed in very limited circumstances. But I don't know what that looks like. But unfortunately, it's pretty much 100%. It needs to be about 100% there at this time. Is there any other questions before we finish up? Okay, thank you guys very much for coming. I hope you guys had a lot. And come back for the 6 o'clock session on React Native. It's going to be wonderful.